Well, dear students, now actually I am going to start the concept of heat engine refrigerator. Before that, we have to learn something very important, that reversible and irreversible processes. To save time, I have written already on the board what is a reversible process. The process which can be reversed in such a manner that all the changes taking place in that process are exactly repeated in the inverse order and opposite sense, and no changes are left in any body taking part in the process or in the surroundings, is called reversible process. We can learn the words, but here I have noticed that we find it difficult to understand what we are going to say. I have told you so many processes: isothermal, adiabatic, isochoric, isobaric. The process is taking place in thermodynamic system, involve extraction of heat, doing work like that. So I am talking about those processes. So I have written again, I am repeating, the process which can be reversed in such a manner that all the changes taking place in that process are exactly repeated in the inverse and order and opposite sense, and no changes are left in any body taking part in the process or in the surrounding, is called reversible process. For example, if we give heat to a system and we get some work done by the system, if on doing the same work on system we can obtain the same heat. You have learned in first law of thermodynamics, when we give heat to thermal system, then it does some work and there occur change in energy like that. But here I am saying, suppose here it is a cylinder fitted with piston, and by taking some heat, it is a source of heat here, hot body. By taking some heat, we obtain some work. If by compressing the piston downward again, coming back, that is change the process in reverse order, means we do work and we get same amount of heat energy from the gas, then process is reversible. But this does not happen in practice. Actually, condition for reversibility is there should not be any force of friction, because when gas was expanded, some work is done against friction by the piston, and when we are bringing back, again some more work is done against friction. So that way we cannot recover the same heat as we have given to a system to do the work. So condition for reversible condition are all dissipative forces. Dissipative forces means the forces which convert energy in the form of heat which we cannot recover back. So dissipative forces such as friction, viscosity, inelasticity, resistance, electrical resistance, magnetic stresses must be completely absent. I hope you are getting my point. The condition for any process to be reversible is that there should not be any type of force which converts uh, energy into form of heat and dissipate that. For that second condition, that process should take place very slowly. ये था, if we expand the gas by giving heat, then difference actually work is done by force F delta x equal to work done, and that work done may increase the kinetic energy of piston. If we perform it slowly, and it will happen only when pressure of gas is slightly more than the external pressure, or there is very small difference of pressure exists between the pressure of gas and external pressure, then it may be called as, it may be nearly reversible. But practically no process can be reversible. Therefore, a reversible process is only a concept. Practical possibility of reversible process is not there. You might be thinking, then when it is not there, why we are thinking, we will learn in next video why we are going to tell this thing. So reversible process is only a concept. Practical possibility is not there. And if any process is infinitesimally slow, then that cannot also be reversible. Any reversibility condition is not that this process will be slow. It will be only reversible if we perform the process and reverse that in such a manner that all the changes taking place in the body taking part are obtainable in reverse process. Now, so reversibility a concept, practically not possible. Now number 2 is irreversible process. Irreversible process. So the process which is not reversible is irreversible, simple. The process which is not reversible is called irreversible. Every process is irreversible. So reversibility is a rule. So reversibility is a rule, and the process is like radioactivity. Radioactivity, diffusion of liquids or gases, or electrical heating. When we pass electrical through conductor, heat is produced. All these processes are irreversible. So this is simply an idea, because we have to understand working of Carnot heat engine. Carnot heat engine बोलते हैं इसको. Now I come to here, heat engine. Heat engine, what is heat engine? A device which work in a cycle to convert heat into work is called heat engine. Actually, wherever heat disappears, motion appears. This is the principle of heat engine. Every engine we are using, like motorcycle, car, bus, they are all heat engine. So, what is the heat engine? Heat engine is a device, in simple word, is a device which works in a cycle to convert heat into work in each cycle. Many definitions are written in the books, but basically heat engine is the device which converts heat into work and it operates in a cycle. The heat engine consists of three parts. The heat engine consists of three parts. Number one, hot body, or we say source of heat. Number two, working substance. Number three, working substance, and number three, cold body or sink. Generally, dear friend, a student keep on thinking now, okay, very good, we will learn how the engine is constructed and we will see different part. No. Our basic theme here is to explain the working of engine, how the concept of heat engine is there. Initially, James Watt there, who proposed that steam has ability to do work. So we will understand here how we can increase the conversion of heat into work, etc. So these have three parts. The symbolic diagram of heat engine, the symbolic diagram of heat engine. Is as shown below. कैसे भाई? Simply we represent here hot body. What is this? A hot body. Diagram. हाँ भाई, at high temperature T1, hot body or source of heat. working substance. And here the sink or cold body. Simple. You might be thinking, कहाँ है hot body, कहाँ है cold body. In case of steam engine, early railway engine, the furnace in which coal is burnt, we produce heat, that is the source of heat. Working substance there in that was steam, and the environment at lower temperature, T2 at low temperature. This symbol diagram. In case of your motorcycle, petrol, diesel, heat engine, actually we send the mixture of air and oil, fuel, in a cylinder. That mixture by producing spark there, is burnt, fuel is burnt. That fuel produces heat. The air takes heat. So that combustion process taking place in that cylinder is source of heat. I think you are getting my point. In case of petrol or diesel heat engine, we send mixture of fuel and air, and we allow the combustion to take place. That combustion produces heat, the source of heat. The air sent with that is working substance, and the surrounding is sink or cold body. Now what happens in every cycle? हमने कहा heat engine work in a cycle. In every cycle some heat Q1, say Q1 is taken from the hot body. Working substance take heat from hot body. You can write working. You can write working yourself or take the book, help of book. Working substance. Dear student, after watching video or after reading the book, write yourself. Only then you can learn. Don't think that is very simple, I got it. No, not so easy. So in every cycle, the working substance take heat Q1 from hot body, converts a part into work, W. And by rejecting the remaining heat to sink, it returns back to the original state. जो हमारा system है working, initially it was at certain temperature, certain pressure. It returns back to original state and ready to take heat from the body again and convert that into work, and rejecting heat to Q to sink, come back to the original position. And in every cycle, a part of heat Q1 comes into work. So this is the working. Now every device has efficiency. So heat engine, efficiency of heat engine. Efficiency of heat engine. Eta, work done per cycle, ratio of work done per cycle, work done per cycle divided by heat taken per cycle is called efficiency of heat engine. So if in every cycle W be the work done and Q1 the heat, then W upon Q1 is the efficiency. From figure, from law of energy, Q1 plus W, Q1 is equal to W plus Q2, or W is equal to Q1 minus Q2. Therefore, eta is equal to Q1 minus Q2, upon Q1, or you can write it as eta is equal to 1 minus Q2 upon Q1. Efficiency of engine will be 1 if Q2 0, means the whole heat taken converted into work. But in practice this does not happen, and therefore efficiency of heat engine always less than 1. I said if Q2 0, if Q2 0 means the whole heat taken converted into work, and Q2 no heat rejected to sink, and then it will have efficiency 1. But this does not happen in practice. Q2 is never 0 practically, and therefore efficiency of heat engine is less than 1. So how to improve the efficiency and how the efficiency of heat engine depend upon temperature of hot body and cold body. To understand this, we will take next topic here, a reversible engine, that is Carnot ideal heat engine, in next video. Thank you.